The next topic in data link layer is framing. What is framing? To provide service to the network layer, the data link layer must use the services provided by it by the physical layer. What the physical layer does is accept a raw bit stream and attempt to deliver it to the destination. The number of bits received may be less than, equal to, or can be more than the number of bits transmitted, and they may not have different values here. It is up to the data link layer. Means the data link layer, what it does is, the main function is to detect and if necessary should also correct the errors. When a frame arrives at the destination, the checksum is recomputed. If a newly computed checksum is different from one contained in the frame, the data link layer knows that an error has occurred and takes steps to deal with it. So for doing all these things, we will be going for 4 different framing methods. So we have 4 different types of framing, we can say. What are they? First one, character count. Second one, flag bytes with byte stuffing. Third one, starting and ending flags with bit stuffing. Fourth one, physical layer coding violations. Okay, these are the 4 framing methods that comes under data link layer framing concept. Okay, let's see one by one. First one, character count. What is this character count? Here, if you observe, character count method uses a field in the header to specify the number of characters in the frame. Here, it is used to specify the number of characters in the frame. Here, if you see, this is the character count. This is 1 character. We can say this one as 1 character. Okay. So, we can tell this as frame 1. Means which contains 5 characters here. See, if you look at this, 1, 2, 3, 4 and 5. Up to here, frame 1. So, which contains 5 characters. When the data link layer at the destination sees the character count, it knows how many characters follow and hence where the end of the frame is. This technique is shown here. Okay. For here we have 4 frames. Frame 1, frame 2, frame 3 and frame 4, which has different sizes. For 4 frame sizes, this frame 1 size is 5 characters, frame 2 is 5 characters, frame 3 is 8 characters and frame 4 8 characters respectively. So, the main trouble with this algorithm is that the count can be garbled by a transmission error. Okay, suppose if the character count of 5 in the second frame, if you observe here in the second frame, becomes a 7. Okay, here if it is going to become 7, the destination will get out of synchronization and will be unable to locate the start of the next frame. Suppose here if frame 1 contains 5 characters. So from here the frame 2 should get started. But when it comes here, the destination will get out synchronization and will be unable to locate the start of the next frame. Even if the checksum is incorrect. See, if you see here the starting frame is 5 and here it is 7. So, the error is arising. Even if the checksum is incorrect, so the destination knows that the frame is bad. It still has no way of telling whether the next frame starts. Okay? Sending a frame back to the source, asking for a retransmission does not help. Suppose if the receiver is getting all these type of errors. So, there is no source of sending the receiver to the sender for retransmission. Since the destination does not know how many characters to skip, over to get to start of the retransmission. For this reason, character count method is rarely used anymore. Okay, because here we are getting errors, and here we are changing the frame 1, frame 2. Here frame 2 is wrong when compared to here A frame, and this, if you consider this as B frame, both are different. Okay, here it has 5 characters. When it comes to the B, here the frame 2 should start with 5, but here the 5 characters is changed to 7. So that is the main reason the character count method is rarely used anymore. Okay, next, coming to the next one, that is flag bytes with byte stuffing. What is this flag byte with byte stuffing? Flag bytes with byte stuffing methods gets around the problem of resynchronization after an error by having each frame start and end with special bytes. Okay, here each frame should start and end with special bytes. In the past, the starting and ending bytes were different, right? In the character count, if you observe, here the starting and ending characters or bytes are different. But here in flag bytes with byte stuffing, the starting and ending bytes should be same, called flag byte. Here we will be having a flag byte. Okay, both the ends, as both the starting and ending delimiter. Okay, here flag. See, okay, this is, suppose if you consider 2 figures, here if you see a figure, here we have 2 bytes, same bytes, flag bytes. Okay, starting and ending delimiters, they are called. In this way, if the receiver ever loses synchronization, it can just search for the flag byte to find the end of the current frame. 2 consecutive flag bytes indicates the end of one frame and start of the next frame. 2 consecutive bytes. Okay. It is easily happen that the flag bytes bit pattern occurs in the data. This situation will usually interfere with the framing. One way to solve this problem is to have sender data link insert a special ESC byte, means escape byte. Okay, just before each accidental flag byte in the data. Here we are going to see this is the original characters, and after stuffing the escape byte before the flag byte. Here that is after stuffing. The data link layer on receiving end removes the escape byte before the data are given to the network layer. This technique is called byte stuffing or character stuffing. Okay, here. Thus, the frame flag byte can be distinguished from one in the data by the absence or presence of an escape byte before it. Okay. The main disadvantage of using this frame method is that it closely tied to use of 8-bit characters. Not all characters codes use 8-bit characters. For example, Unicode uses 16-bit characters. So, a new technique had to be developed to allow arbitrary sized characters. For that, we will be going for starting and ending flag with bit stuffing. What is this starting and ending flag with bit stuffing? Starting and ending flag with bit stuffing allows data frames to contain an arbitrary number of bits and allows character codes with an arbitrary number of bits per character. Okay, it works like this. Each frame begins and ends with a special bit pattern. See, suppose if you consider 0, 1, 1, 1, 1, 1, 1, 0, in fact, a flag byte. Whenever the sender's data link layer encounters 5 consecutive ones, Okay, 5 consecutive ones. In the data, it automatically stuffs a bit, 0 bit, into the outgoing bit stream. Here we are going to, suppose if we are getting 5 consecutive ones, we are going to stuff 0 bits. Okay. This bit stuffing is analogous to byte stuffing, in which an escape byte is stuffed into the outgoing character stream before a flag byte in the data. Whenever the receiver sees 5 consecutive ones coming, 1 bit followed by a 0 bit, it automatically destuffs, that is, deletes the 0 bit here. If you observe B and C figures, 0 bit, just as byte stuffing is completely transparent to the network layer in both computers. So it is bit stuffing. If the user data contains the flag pattern, this flag is transmitted as, means 0 1 1 1 1 0, transmitted as 0 1 1 1 1 0 1 0, but stored in receiver memory as same as the sender. Okay. Here if you construct the C, here the data as they stored in the receiver's memory after destuffing, okay, with bit stuffing, the boundary between two frames can unambiguously recognized by the flag pattern. Okay. And next one, fourth one is physical layer coding violations. What is this? This method of framing is only applicable to the networks in which the coding on the physical medium contains some redundancy. For example, some LANs encode 1 bit of data by using 2 physical bits. Normally, a 1 bit is high-low pair and a 0 bit is low-high pair. High-low, low-high. The scheme means that every data bit has transition in the middle, making it easy for the receiver to locate and bit boundaries. Okay. Thank you.